Hi, welcome to the fourth video in Helius's Solana Frontend Developer course. In today's video, we're going to teach you how to create a developer network Solana Faucet. This is a simple application that will allow you to fund your developer network Solana wallet with developer network Sol. My name is Nathan Galindo. I'm a developer experience engineer at Helius. I'm based in Texas, and I'm a full stack Solana developer. Feel free to reach out to me via email or X to ask me any questions regarding this course, Solana, or Helius. In today's video, we're going to have a brief discussion of what faucets are and their purpose. We're going to walk through the project, and for the majority of this video, we're going to build out the project together. So, what are faucets? Faucets are what developers use to build decentralized applications on blockchain networks. They're not unique to Solana. Faucets are ubiquitous despite what kind of blockchain protocol you're building on, but they're very necessary for testing and developing your applications. Essentially, faucets give you free access to developer network cryptocurrency that allows you to test, deploy, and build your decentralized applications without using real cryptocurrency that costs actual money. So let's get started with today's project. So for those of you that have been following along with this course from the beginning, you should already have downloaded the course app, as well as all the dependencies we'll need to follow along with this video series. I recommend that you go back to the first video of this course if you haven't done so already. But I'm going to assume that you have, so we can move forward. So on my screen, you should see the code to the open source repository that we've downloaded previously. What I want you to do is go into the pages folder and then open faucets, and then launch the two files, finished.tsx and starter.tsx. Those are the files we'll be working in today. And once you have that, go ahead in your terminal. Inside of this repository, type in yarn dev to start the local environments of this project. And then you can go ahead and click preview of card number 2 labeled faucets. So this is a preview of what your application should look like by the time you're done with it. It's a very simple application. Essentially, you will connect your wallets, you will press fund, and a transaction will be sent to the Solana network to essentially fund the Solana wallets that you've connected to the app. Now, it's important to note that using your browser wallet, you should be on the testnet mode. As you can see here, I'm using Phantom. In the previous video, I show you how to install a browser wallet specifically for Chrome. And I install Phantom because it's my wallet of choice, but of course you can install any Solana wallet of your choosing. And I'm just going to show you how to enable testnet mode on Phantom, but go to your settings, scroll down, go to developer settings, and enable testnet mode. Really, we're only going to be using Solana, of course, because this is a Solana course. You can pay no mind to the Ethereum testnet network. But once you have that settled, make sure that yes, you're connected to testnet. Once you connect your wallet, if it connects successfully, you should see the beginning and end of your public key. As you can see here, this is my public key, BSQR, BSQR. Okay, so that looks good. And yeah, this is essentially what your application should look like. If it's successful, the transaction signature of the transaction that you send to the network will appear right here. But what we're going to do is we're going to go to our starter page. This is where we will build out the application right here, right now. What you can go ahead and do is delete this boilerplate code. This should disappear. We'll go ahead and add some React fragments to make this error go away, and we can go ahead and delete that import as well. So this is the code for the finished project that we just reviewed. This is our starter templates. And let's go ahead and get started. So first and foremost, this is a React application. So we're going to go ahead and import React like so. Now I highly recommend you type out everything as I'm typing out, just because it's good practice to type out the code yourself and not copy and paste, especially when you're learning how to use new tools. So right here, I am, typing out. And, maybe it's not super important that we type out the names, right? So I'll cut you some slack there. Typing up the imports, okay. And if you're curious as to what any of these imports do, I've of course left comments that describe each of the dependencies and tools that we're importing. But we can go ahead and get to the code. So first, we're going to initialize the state of our application. So I want to point out, I want you to notice this difference in this finished functional component, this functional component titled finished. We are using curly brackets. Here, we're using parentheses. So in React, you can implicitly return something from a functional component if you use parentheses. However, the caveat is if we want to provide actual logic within our functional component, well, we're unable to, right? So for example, if I go ahead and up here, try to initialize my state, right? Transaction signature, set transaction signature equals react.uState, declare my type and my string. You can see I'm getting a bunch of error messages. So what we want to do, what we want to start out, we want to start out by changing our functional component to simply return, I'm using curly brackets. I want to use parentheses to return our UI like, let me go ahead and switch that again, like so. Okay. So what do we have here? Well, now that we're using curly brackets, we're able to declare logic within these curly brackets, and we return our UI within the return statement. So that's a tidbit for those of you that are new to React. Moving forward, okay, so what have we done so far? We've declared our state, we've initialized our state. This is the information that we will update on our UI components. Earlier, when I was showing you the finished version of the project, I mentioned that, if our transaction is successful, a transaction signature string will appear on the UI. That's the updated state I'm talking about, and that's what we've initialized here. So this transaction signature variable is the state that we'll be updating. Right now, it's set to an empty string. And this green text that we've labeled set transaction signature, that's actually a function that we will use to update this state. So this uState function is part of the React library. It's the most commonly used function in React. You're going to be using it a lot in all the React applications that you build. And this is essentially how it works. First, you declare the name of the variable, and by convention, you declare the name of the function to update that variable by prefacing it with set. So if I name this, punch me in the face, the function would be named set punch me in the face. Okay, so once we've done that, initialized the states of our application, we're going to use a few functions to retrieve information from the wallets we've connected to our application, as you can see here, using these dependencies we've imported from the wallet adapter library. So let's go ahead and type that out. Curly brackets, const connection equals use connection, parentheses, and then we're going to extract our public key, and then this function called send transaction from use wallets. Okay, so did I mistype something here? Yeah, I misspelled that. Quick, simple typo. Okay, essentially this connection allows us to determine whether or not we're connected to our wallet, essentially, and which network our wallet's connected to. This public key variable is essentially just the public key of the wallet that we've connected to our application. And this function is new. So if you're new to front-end Solana development and you're following along with this course, this should be the first time you've seen this function. This will allow us to essentially send a transaction to the Solana network. So super important, and we'll go ahead and dive into that in just a moment. So right now we're going to declare a function to essentially send Solana from one wallet to another, and we're going to call this function, as you can see on this file, fund wallets. It's going to be an asynchronous function, and we're going to grab an event. We're going to specify the type of this event, because again, we are using TypeScript, and then using ES6 syntax. This is an arrow function, and now this is a React convention. We're going to prevent default. Essentially, this means that whenever this function runs, we're going to prevent our app from refreshing. I think it's a feature that you sometimes want to implement in certain functions, maybe not all the time, but it just improves the user experience a little bit depending on how you use it. Okay, so yeah, nothing too important there. If you're curious more about what this does, maybe copy and paste it into ChatGPT. But right now we're going to provide some error handling. So basically, when this function runs, right, we want to make sure that a user has connected their wallets, because if a wallet is not connected to our application, then it's not going to work, right? Because we need a wallet to deposit some Solana tokens into. So we do that by checking if this public key exists, right, that we've accessed up here, or if this connection exists. So if either of these items exist, then that implies that, yes, as a matter of fact, we do have a wallet that's connected to our application. Otherwise, we're going to throw some errors. So we're using React Toastify, which is a library for throwing UI notifications on screen. And then we're also going to throw this error: please connect your wallet. Now, if you'd like, I challenge you to edit this so that it dynamically displays the error of the actual error message you receive when you try to submit a transaction to the network. Right now we have a hard-coded error message, but you can absolutely make that dynamic. So I challenge you to do that if you wish. Moving forward, this is a very, very important step. So essentially, what we're doing is we've connected. When a user connects their wallet to our application, our little mini app is supposed to fund them with Solana tokens. Okay. But in order to do so, there has to be another wallet on chain with Solana tokens to send to our wallet that we've connected to our app. So that's essentially our job here. We are going to spin up a wallet on the Solana chain. We're going to fund it with Solana tokens, and then we're going to submit a transaction to transfer Solana tokens from wallet A to wallet B, which is the wallet the user has connected to our application. So if that all makes sense to you, awesome. Let's go ahead and do that now. So we're going to generate a wallet on Solana, or what's called a key pair. For those of you that are, maybe new to crypto, blockchain, or even cryptography, a key pair is the combination of a public and private key. Okay, so we're going to title this wallet sender in our app, and we're going to access the functions necessary to generate this wallet through the Web3 library. Generates. We're going to use that generate function. And so just like this, we've generated a new public and private key pair. This is our wallet. So we can even just leave it a little comment, new wallet. Okay. So now we need to check the balance of this wallet and send funds if needed, just like I've prefaced on the finished document. Okay, so really, maybe it's not super important that we need to check the balance of this wallet. Since we've just created it, we know for a fact that the balance is going to be zero. It's not going to have any funds. But for the purpose of practice, I think it's good that we learn how to check the balance of a wallet. So the code is pretty simple to do so. We're going to create a variable called balance. We're going to access this connection object, and we're going to use this method called getBalance. And we're going to pass in this variable. This is the public key of the new wallet that we've just recently created. So we're saying get the balance of this wallet that we just recently created and store that amount in this variable called balance. And so if this balance is less than, we're going to use this little variable here. I can explain that in a moment. But if this balance is less than one sol, essentially, we're going to use this request airdrop method, and we're going to pass it the public key of the wallet we just created, and then we're going to specify how many Solana tokens, how much sol we want to airdrop into this wallet. And we're going to say Web3 LAN ports times 1. So this is saying we want to deposit 1 sol token inside this wallet. Now, if we put 0.5, we would be depositing half a sol token. If we put 2, we'd be depositing 2 sol tokens. You could put whatever number you want. It really shouldn't make a difference. I'm just going to put 1 for simplicity's sake. Now, for those of you that have never seen this item before, LAN ports per sol, it's important to note that a LAN port is the smallest denomination of a sol token. 1 LAN port is equal to 1/1 of a sol token. So 1 billion LAN ports equals 1 sol token. This is just easier than typing out 1,000,000,000,000, etc., etc., etc. So just for simplicity's sake, I like to use this little import. So just like that, we've created a new wallet on the Solana blockchain. We've checked the balance of the wallet, even though we, maybe didn't really need to, but it's good for practice. And we've conditionally requested an airdrop of one Solana token to this wallet, essentially. Fantastic, great progress. What's next? Okay, so like I said, with our application, user connects their wallet, and then a wallet that we've spun up sends SOL tokens to this user's wallet. So we spun up the wallet, we funded it with SOL. Now we just want to create the transaction and submit it to the Solana network, where we transfer SOL tokens from wallet A to wallet B, the user's wallet. So we're going to do just that. We're going to create that transaction using this transaction object from the Web3 Solana.js library, and then we're going to send that transaction using the send transaction function. So let's go ahead and create this transaction object. So transaction equals new web3.transaction. We're creating a new transaction object, and we're going to add the contents of this transaction, essentially. So, what content are we adding to the transaction? Well, we want to invoke the system program. So the system program is one of the core programs on Solana that's responsible for a few core features. One of those features is transferring cryptocurrency tokens, Solana tokens specifically, from one wallet to another between accounts. So we want to invoke the system program. We want to use the transfer function, and we want to specify three things. Who is sending the money? Well, that would be our sender. To whom is, who is receiving the money? That would be the wallet that's connected to our application. We get that information by accessing this public key. And how much do you want to send? Well, we funded our wallet with one SOL. So let's go ahead and send one SOL, just like so. We can go ahead and add a comma there. Why do we add a comma? Because really you can add multiple items to a transaction, because we're only doing one operation, which is transfer SOL from one wallet to another. We only add, just this. That's all we need. Okay, so we've created our transaction. A transaction's a bundle of instructions that will perform, some operation or operations on the Solana network. Now we want to send that transaction to the Solana network. And we do that by, first and foremost, this is just best practices, using a try-catch block. So before we even put in our business logic, I want you to instantiate a try-catch block. So what is a try-catch block? For those of you that are new to React or JavaScript in general, essentially, when we're performing some kind of asynchronous operation, it's usually best practice to use try-catch blocks in order to catch any errors in case our operation fails for any reason. So in the try, we want to try, right? What do we want to try to do? It's pretty semantic. Well, we want to try to create a signature, and we're going to do that by send transaction. What transaction are we sending? Well, the transaction that we specified right above. We're going to feed in our connection variable that, tells the function, what network are we on? And then who's signing for this transaction? We're going to pass in the sender wallet. Okay, so there we have our signature. Once we have our signature, so if this send transaction function works the way we intend, then this signature variable will be populated with the transaction ID of this operation on the network. And then we're going to update our application state using the set transaction signature function we defined earlier, and we're going to pass in that variable. So essentially what's happening here is we want to try to send this transaction using this transaction object on the network, that our wallet's connected to, and then we sign for that transaction. And then if all goes well, then we're going to update this transaction signature variable using this function, passing in this transaction signature. Now, what if it goes wrong for any reason? Well, we want to throw an error to notify the user that something went wrong. So we're going to use, again, Toastify for doing that. Error, funding wallet. And then we're going to throw that error message as well. And just like that, that's pretty much the business logic for our application. All we have to do now, this isn't absolutely necessary, but I think it's best practices. We're going to create a little schema. Oops, I'm going to spell that. Schema for the type of information we want to display on our app. Again, this isn't, something you 100% need to do. You can hard code this information into the UI components that we're going to build in just a moment. But personally, I think it's best practice to refactor the items you want to render on screen. And I'm just going to go ahead and copy and paste this URL because it's not super necessary that we type out all of this. I am going to note that this is the URL to the Solana Explorer. So we can check that out here, the Solana Explorer. This is a block explorer on Solana. There are multiple different kinds of block explorers. This is just the one that I've used in this application. Essentially, this it uses string interpolation to programmatically insert the transaction signature of this transaction that we try to execute here. So you'd be able to reference the transaction that we create on the Solana Block Explorer. Just a quick note. Okay, so now that we have all of this business logic and this little schema here, we can go ahead and create the meat of our app, maybe the most exciting part of our app, which is the UI. Now I'm going to, probably copy and paste the CSS for this part, just because it's not super, the CSS isn't, the super most important part of this application. But for those of you that want to study the CSS of this app, I highly recommend you maybe take your time typing it out and maybe even copy and pasting it into ChatGPT and letting it explain to you exactly how this CSS works. That would be especially useful for those of you that are new to developing front-end applications. But what we're going to do is we're going to specify a main tag, and then we're going to copy and paste this CSS here. And then we're going to create a form, essentially. This is going to be a form. Now the form takes a function called onSubmit, and we're going to pass it an event, and then our fund wallet function, and then we're going to pass it that event item. And of course, we want our form to have some kind of styling, so we're going to pass in class name, and then give it the styling that I've already defined. Now here you can see that we have kind of two main items, the header of our application and the area of the application where we render the transaction signature, essentially. So we can go ahead and specify those two div items, and we can even put some comments like so, header, and then the comments down here, title, then we can title this just content. Feel free to put in a different title if you think there's a more appropriate title. But we're going to give this some styling, just like so. And then we're going to give it a title. So it can be, I gave it an H2. I called it Faucet, and I inserted a little emoji to have some fun. Class name, text large, font semi-bold. I think that's pretty semantic what I'm doing there. And this is our button essentially. So if we go back to our application, this is the button we're creating. This is a button that's going to initialize or it executes the fund wallet function we've defined earlier. And so we're going to say type submit, because remember, this is a form. So when we click this button, it's going to submit this function that we have here. So type submit, and then we're going to give it some styling. I've already declared my aesthetics, so I'm just going to import that. But you can, of course, give it your own aesthetic touches if you feel the challenge to. I think I actually challenge you to do that. It would be good practice for you. So just to walk through what we've created here, we've instantiated a form. We've created the header with our title and a button that when we click it will execute this function. Now you can see that we're passing in something as an argument to this function, fund wallet. And that's what we have here. And that's what we use to prevent our app from refreshing whenever we execute this function. Okay, so moving on. We're going to create a new div, a new container for the content section of our app. We're going to give it the styling. There we go. Now, this part looks a little bit more interesting and it might look a little bit scary if you're new to React, but I promise you, it's not scary. It's pretty obvious what we're trying to do here. We're going to give this some padding. This unordered list, that's what this HTML tag means, UL for unordered list. And what items do we want to list out? Well, we want to list out each object or item within our output array. So here we're really only listing out one item. If we duplicated this, then we would be listing out 3 items, right? But we're only listing out one because that's, for simplicity's sake, that's really all we're interested in. We're going to map over this array using the map method. We do this like so, outputs.map. Okay, oops. So outputs.map. Now for each item, hold on now, I'll explain myself in just a moment, but for each item, we're going to return something. Now I want to note 2 things. First, notice here that again, I'm doing an implicit return using parentheses, right? So we're implicitly returning some object, each time this function loops over something in the outputs array that we specified here. If I did curly brackets like so, then notice how I'm getting an error. That's because we're not returning anything. I would need to create a return statement like so. But it's cleaner syntax in this example to just use the parentheses. Okay, so what are we returning? We're going to return this UI element. I want to touch on this object item here. So what's the item? What does this item represent? Well, you can see actually, this is actually pretty smart. It's discussing this title dependency href item object within our outputs. So this map method says, okay, we're going to take this outputs array, and for each item in this array, an item being this object, we're going to loop over each item and we're going to render something, right? Okay, well, what are we going to render? We're going to render a list item like so. So li, like so. And then we're going to give this a key because React demands that we have a key. So we're going to access this key as our title. That's going to be our key title. We're going to give this some styling. I've already declared some styling, so I'm just going to give it that. Oops. My bad. Let me just fix that real quick. I kind of copy and pasted wrong. Okay, so there's our styling. One moment. So let me show you the reason why I did it like so on the finished documents. Basically, we're going to extrapolate the items within each item by first declaring parentheses and then using curly brackets to do extrapolation. And then we're going to declare each item within the object. So title, dependency, and href. And then outside those curly brackets, but within the parentheses, we're going to instantiate an index variable that essentially just indexes each item within the outputs array. So this would be index 0. And so that's how we can do that. We're going to remove that, and there we go. So we're going to instantiate a list item, one list item per item in the outputs array. And then we're going to put in the content. So we have a p tag for title. We're going to type in our title. We're going to give this tracking wider. This just puts it space between letters. And then finally, we're going to say if there's a dependency, right? So if this send transaction function succeeds, which means that, this signature populates this transaction signature field. So if there's a dependency, then we're going to render an A tag. An A tag is in HTML basically is what you use to specify hyperlinks, so links to other websites. And we're going to give this some properties. So href is the actual URL that this A tag points to. Target equals _ blank means that when a user clicks on this A tag, it's going to open up a new page. Rel no opener no refer is part of that, and then we're going to give that some styling. So specify the class name of this HTML item, and then we're going to input 2 items within this A tag. We're going to render the dependency, which is essentially the transaction signature. We're going to convert it to a string, just to make sure that's a string. And then we don't want to render all of it because it's a long string. It's about 32 bytes or 32 letters. So we're gonna slice that. We're gonna make it a little bit shorter. We're gonna slice it to 25 letters, and then we're just gonna put some ellipses, and then we're going to import an icon from this library, Hero Icons. It's probably my favorite icon library. It's free to use, and I just use it all the time. Highly recommend it. And then we're going to edit the width, and we're going to add some spacing between this icon. and this string of text we've added here. And just like that, we've essentially recreated the Solana Faucet application that we have in our finished document. Okay, so here's the moment of truth. Now I do want to make sure one more time that I'm on the testnet. So I'm on testnet, good. I've connected, and I'm going to go ahead and click this button. Now, okay, let's talk about this. This is a good learning moment. We can look at our console log. So let's go ahead and look at our console. So internal error at connection.request airdrop. So what's happening here? Well, we can go to this line of code, connection.request airdrop, and it's saying that there's a failure happening here. This function isn't going through. You can see that when we click this button, it tries, and finally it fails. And the error message we're getting is, you have requested too many airdrops, wait 24 hours for a refill. Essentially, that's the error that we're getting. So unfortunately, this is kind of an issue with the Solana developer network. It's not really an issue with our code. This is good news and bad news. It means that our code's working. We are hitting the correct endpoints to request an airdrop, and et cetera, but these methods just aren't working for us right now, probably because the Solana network is a little bit congested. So for those of you that have watched our earlier videos and installed the Solana CLI, I might have introduced you to the Solana airdrop function in the Solana CLI. And so basically what this does is it hits the airdrop function, just like our code is doing, and it's saying to airdrop our wallet on our computer 1 SOL token. But if I press enter, you can see that the request failed. This can happen when the rate limit is reached. So that's just the name of the game sometimes. Sometimes these airdrop requests simply don't work out for us, and that's unfortunate, but it doesn't happen all the time. So like the error message told us, when we get these kind of errors, it's best to wait a little bit of time before we can hope that these transactions go through. So kind of a bittersweet end. We know that our code is kind of working the way we expect it to, but because of some congestion issues on the Solana network, we're unable to airdrop Solana tokens to the wallet that we spun up earlier. Thanks for watching this video. Feel free to get connected with me on X, to connect with the Helius team on Discord, or to learn more about Helius on our website. I look forward to seeing you in the next video. Bye.